All right. So when we take a look at my function, suppose f of x is equal to 2x minus 1. Instead of asking the domain, I'm going to switch up my question and say, what valid inputs or what valid x values will work in this function? Well, here it would be all x values. No matter what your input is to f, your function will always work. You're able to multiply any number by 2 and subtract 1 from it. It always works. Yet my function h of x, well, what is the valid inputs of h of x? Well, the value h, the h of x, well, that's a good question because now we're dealing with a square root. And if we're dealing with real numbers, which in high school we are, we have to make sure that my radicand is non-negative, that it's 0 or positive. In other words, that x is greater than or equal to 1. And that should make sense. So here, my input, and I'm going to call it input and not x, my input would have to be greater than or equal to 1. All right, so we're going to determine the function along with the domain. My function f of h of x is simply the f, and if I input x into my function h, I get the f of the root of x minus 1. And if I apply my function f, it's simply 2 times my input minus 1. And my input is the root of x minus 1. That's what I got. So how did this happen? So here, what values of x will work in h? Well, I guess my domain of h of x has to be x greater than or equal to positive 1. That's the domain of h of x. Now, the outputs of h of x, now this is going to be crazy, but if I'm going to put the outputs of h of x here, what are the outputs of h of x? Well, the outputs are going to be greater than or equal to 0. But remember that my outputs of h of x are now going to be the inputs of f of x. And what inputs work with f of x? They all do. So the domain of f of h of x relies solely on the domain of h of x. So the domain x exists such that x is greater than or equal to 1, where x is element of the reals. Now, that was all fine and nice, and hopefully that works. So I was really restricted by the domain of h of x, and that determined my whole domain for the function. Now, I believe we might be headed into a trickier situation here. So what is my function h of f of x? Well, my function h of f of x, so the h and f of x is simply described as 2x minus 1. If I apply my function h to that input, it is the square root of 2x minus 1 minus 1, or it is equal to the square root of 2x minus 2. Now, I get that I'm going about this a weird way, but this is what I'm going to do. For what values? If I apply my function f to my x, what value of x work? So f of x has domain x is element of the reals. And really, what must we ensure? Well, we must ensure that my radicand is greater than 0. So what is my inputs that are going to work into my function h? Well, all inputs greater than or equal to 1 work. And what's being inputted is 2x minus 1 has to be greater than or equal to 1, and there's my inequality for my domain. So very simply, I could solve this by adding 1 to both sides and dividing both sides by 2. So really, and sometimes it's easier to think backwards, my function h. What functions will work in h? Well, only those that have a valid f of x value that will work in h. And which ones work in x? So it's almost like working backwards. Similarly, so there's my domain. I know what some of you are thinking at home. You have this beautiful little radical, or radicand underneath. Can't you just argue that your radicand has to be greater than or equal to 0? And in this case, it does work. There may be some other cases where you're going to have to employ a more robust argument. This might be the one. I'm hoping. So if g of x is equal to x squared, f of x is equal to the root of x minus 4. So g of x has, as you guys are probably familiar, the domain, we have all inputs that will work. But f of x, what we're saying is that the inputs have to be greater than or equal to 4. And I'm hoping that you're able to see that. So what I'm going to do is I'm going to ask, well, what needs to be? Well, I know that my f of g of x is that if I'm applying my function f of x last, that means that g of x has to be greater than or equal to 4. There, I took a different look at things, right? If I know that my inputs of f of x have to be greater than 4, why don't I just say, well, g of x has to be greater than or equal to 4. Now, where is g of x greater than or equal to 4? Well, g of x is just simply described as x squared has to be greater than or equal to 4. Now, when is x squared greater than or equal to 4? Well, it's under really two conditions. It is when x is less than or equal to -2, or x is greater than or equal to 2. Please note that I use the word or, and it's the mathematical or. It would be incorrect to say and. All right, let's see. I'm going to calculate the domain of g of f of x. Well, if I take a look at my function g, well, g is going to have some input. But no matter what I put into g, the function g always works. So g is not the limiting factor in this. However, what is true for the function f to work? Well, for the function f to work, x minus 4 has to be greater than or equal 0. For my function f, that must be true. And when I solve for this, that means that x is greater than or equal to 4. So those are the values that will be relevant for my function f. Now those will give all sorts of outputs, no doubt. But no matter what those outputs are, when I do the function g, those outputs would always work because the function g takes any output because the domain is x's element of the reals. So really, the domain for this function is going to be x exists such that x is greater than or equal to 4 for x's element of the reals.